In this video, we're going to be talking about fractals. And to introduce fractals, I'm going to make something called a Koch snowflake. Now, a fractal is a self-similar, self-generating figure. So I've started here with an equilateral triangle. And what I'm going to do is I'm going to repeatedly dilate this triangle in order to make a figure created of similar dilated figures. So this is going to be made up of only equilateral triangles. And so I'm going to start by, I'm going to find the midpoint for all three of these sides. Find the midpoint. And then I will choose the dilation tool down here. Maybe going the wrong way. There we go. The dilation tool. And I'm going to dilate this figure about point D. And I'm going to make it to be 1/3 of the size. So what's going to happen here is this is now, each side length is 1/3 of the size that it was. It dilated about point D, and because I did negative, it also reflected or rotated 180 degrees around point D. And I'm going to do that about point F and about point E as well. And so what we're looking at right now could almost be considered, it looks sort of like a sheriff's star. But I'm just going to do this process again. So I'm going to find the midpoints. And I have several midpoints to find. So the midpoints for each of these sides. Oh, I already did that one. And just for the purposes of what GeoGebra is capable of doing, I needed to recognize that A, C prime of 1, B prime of 3, back to there is a triangle. Same up here. This is a triangle. And then this down here is a triangle. All right, and I'm going to do the dilation again. So I'll start with this down here. I'll dilate about N to be 1/3 the size. I'll dilate, pick the wrong thing, cancel. About M to be 1/3 the size. And I'm just going to keep following this pattern around. And there is our pattern that we made here. If let me zoom in some so that it looks, so you can see more of it then. But hopefully you can see how it sort of would be considered a snowflake. What I would do next is find the midpoints for each of these three triangles here, each of these three triangles here, and so on, and then continue to do a dilation by -1/3, so it also rotates it at 180 degrees in the process. And it would just continue to make smaller and smaller and smaller figures. Let me just do it, and I won't do all of them, but I'll talk about it up here. Midpoint. And I'll make sure it knows that this is a triangle. And let's do our dilation. So the dilation of our triangle, if I can get that selected. Triangle about Z1. Triangle about there. And so, I mean, again, I could zoom in here, and what you're going to end up seeing the more I zoom in is it's just going to continue to make the same shapes that I was making before. If I zoom out, you can see my original big old triangle there, and so how it's kind of building there, and all of these points are sort of in the way. So this is what the figure looks like after I've removed all the points and lines. And again, I just did this portion over here, but you can see my big triangle and how it built into these smaller triangles, and then how it built into these smaller triangles, and how they built into these. And if I zoomed in on this, again, it would be a similar, self-repeating, nothing but equilateral triangles being used to make that. So there's one, there's one, there's one, and so on, right? All of these are equilateral triangles that have just been dilated to 1/3 for each side length and added on here. So for now, we are done.